So hello everyone, and today we'll be seeing one of the problem from Geeks for Geeks. It says two equal sum subarrays. The problem is simple. We are given an array of integers ARR and we need to return true if it is possible to split it into two subarrays without reordering the elements, okay, such that the sum of two subarrays are equal. If it is not possible, return false. Fairly simple. Now let's see an example. We have an example like this with this sample input, and if you can just take these subarray, the sum would be 10 and the rest of subarray sum would be 10. So the output is true. Same with this, you cannot divide the array in such that it will be equal to equal subarrays, so that is why it is false. Again, they expect us to do it in O of n time complexity and without any auxiliary space. So how can we deal with this? I'll take an example. I'll take this example with this and we'll understand how can this be solved. First of all, let's make these things simple. We don't want unnecessary things. Yeah. And yes, we have this example and we know that we can divide the array here. That means sum of this part and sum of this part is same. So I'll call it as S1 and this also S1, because why? Both are same. So S1 plus S1 should be sum, or let's say it should be 2S1, right? And which is nothing but sum. So if I find out the sum, I'll get S1, correct? How can I get S1? Is S1, or I'll say here target, or in other case you can say S1 is equal to sum divided by 2. That is where the gist of a problem is, and I need to understand, can I get a subarray who has the target as a sum? And understand, this is a subarray where we wanted to start directly from 0 and not other index. Why not other index? That's a very good question, because we have to split the array into two parts. Understand, if I'm having an array like 0, 1, 2, blah blah blah, to I don't know n minus 1, n, and if I started from 2, then I'll go to subarray like this, and it will not create two subarrays, but it will create three subarrays. This is one subarray, from 0 to 1 would be another subarray, and from n minus 1 to n would be another subarray. So it would never be two subarrays. So let's start from 0 and understand whether we get a target or not. So with these things in mind, can I just pick numbers like, hey, if I want, let's take another example. If I'm having a sum like 4, 5, 6, 7, 8, 9 and 10, if I want 10, then can I take 3 and 2 only? No, that would not be a subarray. Else I cannot pick numbers randomly, because we want subarrays and not subsequences. That is the thing. So with that things in our mind, let's get started. We want sum, so what I will do here is arrays dot stream of a dot sum. This will give me a sum, and if at all sum is an odd number, then I'll return false, because no matter how hard you try, odd numbers cannot be broken down into two different things without any decimal. So, and everything is integer, so no point of decimal. I'll also find out the target then. Int target is equal to sum divided by 2, and I'll also have a runner. What is runner? Runner is nothing but a point where which would take your sum, like it's just a variable which will keep track of your sum starting from 0 to the index whatever you are upon, and it will keep track of numbers, sum of the numbers. So I'll take numbers then, because obviously we want numbers from an array A. I'll keep runner plus equals to the number n, and once I keep the runner active, I will also desperately check if runner is equal to target or not, because that's what our goal. And if at all it is, I'll just immediately return true without any doubt. Else, if I'm done with the loop, everything is done, I cannot find runner is equal to target, I'll get out of the loop, I'll return the false, because I have iterated all the array but I have not found anything. That's why return false. Let's compile this one and check out. Oopsies, what happened? Hey, what happened? Oh wow, it's taking time. Nice. So it has passed the sample test case. Let me try to submit this one for, yeah, and it is properly submitted for all the test cases. And again, we respected the time complexities of n again, and auxiliary space complexities of 1. But my question again lies the same: can we do it in only one parse? Yes, we can. I am quite excited how you are guys going to approach this one. Do let me know how do you approach this one, and I'll see you in the next one.